So I mentioned before there was that large table of polyatomic ions. Well, it wasn't all polyatomics, but I told you to pay special attention to the polyatomic ions. But actually there are a whole bunch more polyatomic ions that you'll need to know. And instead of just memorizing these, I'm going to show you how you can use the periodic table to predict what the name is without having to memorize an extra, well, something like 48 polyatomic ions, okay? So these are all oxyanions, which means they're negatively charged. The oxy sounds like oxygen, right? So it indicates that there are oxygen in it. And what these are is that they're one nonmetal with a whole bunch of oxygens attached, all found at the right-hand side of the periodic table, okay? So basically, all of these oxyanions end in the ATE form. So ATE. So arsenate was one on our list. This is the arsenate ion. This is the ATE form. The interesting thing is there is also three different types of quote-unquote arsenates. There's perarsenate, there's arsenite, and there's hypoarsenite, okay? And it all depends on how many oxygens are in the formula. Now, changing the number of oxygens doesn't change the charge on that anion, but all it does is change the number of oxygens and change the name, okay? So if you have one more oxygen than the ATE form, this basic arsenate form, okay? Add one more, so you go to AsO5 3 minus, it becomes perarsenite, okay? Perarsenite. If, however, you drop one oxygen from this formula, the name changes, the end of the name changes from arsenate to arsenite, okay? So AsO3 3 minus becomes arsenite. If you drop two oxygens, in order to indicate that second change in oxygen, if you have two fewer oxygens than the base arsenate form, you actually say hypo on the beginning and say arsenite. So notice there's a prefix for one more. There's a different ending, so suffix for one less, and then there's a prefix and a different suffix for two fewer oxygens. Okay. With that in mind, let's look at this this little caption of part of the periodic table. Okay, this looks an awful lot like your periodic table. So over here you have noble gases, right? And over here, look at the beginning of these formulas. They're all halogens, right? These are your halogens. This is oxygen, sulfur, selenium, tellurium. Okay, what these are the basic or the base forms of all the oxyanions. Okay, so this one. So normally we would say this is fluorine, right? This is the element fluorine. Well, if this is element fluorine, F-L-O-R-I-N-E, then you would expect that the oxyanion form would be fluor 8, right? Fluorate. So this is what this is. This is fluorate. This is chlorate. This is bromate, and this is iodate. If you look at over here, this is sulfate, selenate, tellurate, all the way down. Okay, so these are the base forms. So now with this information and that information, you actually know not just these 8 forms, but also the ite, the perite. So if we were going to write what is per fluorate, what is that formula? Well, based on that last bit, that would be FO4 1 minus, right? Because it's got one more oxygen than our base form. Notice the trend here. Everything in this 7 on the periodic table, 7 all the way down, has 3 oxygens in the 8 form. Everything on the inside of that 7 has 4 oxygens in the 8 form. And then if you look at the charges, it's -1, -2, -3, -4. And then at the top, the only difference is we go -1, but since there is no O 3, right? Because that would be just O4. You start over. Minus 1, start minus 1, minus 2, minus 3. Okay? So keep that in mind when you're looking at the periodic table. If you just add 3 oxygens to any of these elements and give it a charge that corresponds to what column it's in, well, if you do that, then you have the oxyanion. And then if you add 1 fewer oxygens than that, you would have the oxyanion with like carbonite versus carbonate. So COO2, and that would be a 2 minus, right? Would be carbonite. CARBONITE. Alright? So those are, with that little bit of memorization, 3 and 4, and start over, and the charges, you now don't have to memorize all 40 of the oxyanions, or 48, I calculated at one time. Alright? So keep those rules in mind.